Hi everyone, we move to section 3.4 called the chain rule. So you might think of this as the king of all derivative rules. It's the one that tends to be the most challenging for students. And the reason because it's a little bit different than some of the other rules or all of the other rules that we've learned up to this point. And it's got kind of a scary name, right? The chain rule is a bit intimidating, but we'll see the reason for that name and we'll go through a lot of examples here. So you see that first one, f of x equals the quantity x to the third plus 1 raised to the 10th. It turns out we can very quickly take the derivative of that function with the chain rule. We'll also look at y equals the cube root of the natural log of x, kind of an intimidating function there. But we will be able to fairly quickly be able to take that derivative. And we'll see this one as well. G of x equals 2 times e, and e is raised to that entire polynomial. So that's e raised to the x squared plus 4x plus 6. We will be able to perform that derivative very quickly with the chain rule. Okay, so you notice what are we really working with here? Each of these examples are composite functions. So composite function, if you think back to algebra, usually we write it as f of g of x. So the idea is there's one function inside of another. So if you think of f of x, kind of think like x to the third plus 1 is inside this raising to the 10th. So this would be like the g, and then the f function would be like raising to the 10th power. Or this middle one, the g is the natural log of x, and that is inside a cube root. This last one is not quite as clear. We're going to talk about this one, exactly what's inside of what here, and maybe and if you do, if you think you have a good idea of what the g is here and what the f is, then good for you. But I'm going to kind of leave you in suspense on this one because there's definitely a different feel than the others, although it will still use the chain rule. Okay, so let's talk about how would we take a derivative of a composite function. Here it is, the chain rule. And you see I've got some arrows there, but I'll save that. For once I explain what's going on here. Okay, so we're thinking the derivative of our composite function f of g of x. And here's how we take it. There are two parts, generally speaking. So what we do, we start from the outside and work inwards. So we take the derivative of f. So we see f prime. But inside of that, we just copy the original g of x. Okay. And then the next part, we multiply, and that's where we take the derivative of the g prime x. Here's a handy way that I like to explain it, and I think makes it easier for students when we see the examples. Think of that original composite function as having an outside and an inside. So the inside, of course, is the g of x. The outside is the f. So when you go to take your derivative, think it's the derivative of the outside, so f prime, times the derivative of the inside, g prime. One thing you got to be very careful about is when you take the derivative of your outside, you're always copying the g of x within it. So of course we're going to see those examples here very shortly. And there's a common mistake to try and do both derivatives like in the same step. But don't do that. Take just the derivative of f and then copy the g, and then multiply by the derivative of g. And you see here with the result, this is where the name comes from. We're thinking of these as like two links in a chain. So link number 1, link number 2, and all of it together is the derivative. So there's like these two links forming the chain. Derivative outside times derivative inside. Okay, let's see it in action with our first example that I showed you. So our instructions are simply to find the derivative, and we're going to look at this, and I'll try not to reveal too much. There's our answer over there. Let me just cover that up. Okay, so back to part A. F of x equals x to the third plus 1 raised to the 10th. So first thing we want to do is recognize this is a composite function. There is an inside and an outside here. And we already kind of talked about that a few minutes ago, but let's kind of remind ourselves, okay, so quantity x to the third plus 1 to the 10th, what is the inside and what is the outside? And well, the inside is the x to the third plus 1. The outside is the 10th power. I think this way of thinking inside outside is very helpful because what's inside is literally what's inside the parentheses. And that will very often be the case when we are looking to use the chain rule. And then what's outside the parentheses, well, that's the outside, the 10th power. Okay, so let's think about how the derivative works. We're supposed to take the derivative of the outside first. And then we'll multiply in the derivative of the inside. So how's that going to go? Let me kind of, I've got it all there, but let me show you it in writing. I think it'll be easier to digest if we just kind of do this from scratch. Okay. So we're going to say, all right, derivative of the outside. So that's the derivative of a 10th power. So that means the 10th power comes all the way down in front. And then we'll have these parentheses. And it's going to drop to a 9th power, right? So there's the derivative of the outside. The 10 comes down and it drops to a 9. So that's like the f prime. But wait, it says inside of that is the original g. Okay, so what goes in these parentheses? Well, we just copy what is inside there for now. We don't change it, we just copy it. X to the third plus 1. So there's f prime of the original g. And then we'll say, okay, there's the derivative of the outside times, and now here's where we take the derivative of the inside, and derivative of x to the third plus 1, you guys know, is 3x squared. And then I've got, these kind of pointers of what we did. There's the derivative of the outside times the derivative of just the inside. And we've got it. If you remember what I said back in the previous section, I said, when it comes to tests or a quiz, if all I'm asking you to do is find a derivative, then you won't have to simplify. So if this was on a quiz or a test and I just said find the derivative, you could stop right here. There's your quiz or test answer. That said, this one is not too hard to simplify, right? 3x squared, maybe multiply it by the 10. We could write it like this. So this is maybe what we'd call the simplified version, like that. And there you go. So on a test, this is all I need to see. But, in this case, not too hard to clean it up. There you are. Now, some of you might have been thinking, hey, do we really need the chain rule for this example? X to the third plus 1 to the 10th? Now, the truth is you don't absolutely need the chain rule, right? We could multiply x to the third plus 1 by itself 10 times. Right, that's possible. We can multiply this all out 10 times, right? Distributing, foiling, all those things. And we'd end up with one long polynomial. and then we could take the derivative, just of that polynomial, and we'd get an equivalent answer, but wow, the chain rule sure makes that a lot faster. Just take that 10 down, and then boom, and then take that derivative of the inside, right? So we can avoid very tedious work. And this is only to the 10th power. Imagine what if this was to the 100 power? You would not want to multiply that out 100 times. No thanks. Okay, let's see another one. And again, I'm kind of revealing a little bit too much here at the beginning in my notes. Part B, well, let's look at that second example I showed you guys at the beginning. Y equals the cube root of natural log x. So we want to identify what's inside and what's outside, but we'd also like to rewrite that cube root so that we're able to take a derivative, and you might know what I'm talking about, so that's what I've got right here. Let's think of it as the natural log of x within parentheses raised to the 1/3, because a cube root is the same as raising to the 1/3 power. And at that point, let's identify what's inside and what's outside. So again, we're literally, what's inside the parentheses is the natural log x, so that's the inside. And this raising to the 1/3 is the outside function. So this one's going to work in a very similar way to the last problem. We just have this fractional exponent here, and we've got natural log of x inside of it. But okay, how's this derivative going to work? And I think I'm actually going to, again, so erase what I've got here, so we can, I think it's easier if we talk through it each step. Okay, so we think derivative of the outside, so that means the 1/3 comes down. And I'll leave this blank for now. We subtract 1, that would be negative 2/3. So that's like the f prime in the formula. That's the derivative of our 1/3 power. And we know for the time being, we're just going to copy that natural log x right there. So there's the derivative of the outside. Then we're going to multiply. And at this point, now we take the derivative of what's inside, and we know that is 1/x. And we got it. Derivative of the outside times the derivative of the inside. If this was a quiz or a test, you could stop right there. No need to clean it up. That looks great. Unsimplified. However, it's a good idea to practice simplifying these sort of things, because we're going to have to be doing that pretty soon anyway. In this case, this is a nice simplified version. Let's make it just a big fraction. I see a 3 is in the denominator, right? X is in the denominator, and the natural log of x raised to the 2/3 is in the denominator because it's got a negative exponent. So I could say 1/3x natural log of x raised to the 2/3. There's your simplified version. And this version might be a lot easier to plug a number in. It's easier to think of it this way than the unsimplified way. Okay, we got one more before we stop this video. That last example we saw at the beginning, g of x equals 2 times e, and e is being raised to x squared plus 4x plus 6. And we are supposed to identify first the inside and the outside. Turns out there's really no way to rewrite this like we did part B. So we kind of think, well, I don't see any parentheses there like those other problems. So what's the inside and what's the outside? And then, and this one can be kind of tough for students. So when you're first learning it, I'll tell you this. If there were parentheses somewhere here, they would go around that polynomial. And we don't write them because we really don't need them. We know that entire polynomial is in the exponent of e. But if there were parentheses, that's where we'd put it. So the x squared plus 4x plus 6, that's the inside, which means it's the e that's the outside. And now this almost seems backwards for a moment. In the previous problems, right, even we can just look back to part B, right? The exponent was the outside, the inside was the natural log x, and very similar for part A. But here they're reversed. Here the exponent is the inside, and the outside is the e. What's up with that? Okay, here's another tip on how to identify inside and outside. So a lot of times it's literally inside parentheses. This is the one exception where you have an exponential, where it's not literally inside parentheses. But it's gotta be the x squared plus 4x plus 6 is the inside. Here's why. The inside always has the variable. Okay, so like here, that's where the x is, the natural log x. The 1/3, there's no variable there. That's a constant, right? Exponent. Down here, it's reversed. This e is the constant. And there's where the variable lies. The variable is always in the inside, and the outside is always some kind of number. So, or it's an operation, but usually that operation looks like a constant. So it's a constant exponent. It's a constant like base being raised to the variable. Hopefully that helps you out. Okay, so how would we take the derivative then? Well, let me erase this, and we'll do it together instead of having it already there. I think it's easier that way. First of all, what's up with the 2? So the 2 is a constant multiple, so that's just going to come down. That constant multiple just carries along. Okay, then we get to the outside. Hey, what's the derivative of e? Right, the derivative of e is itself. So we just repeat the e, and then this part would get copied here. So there's the f prime, and then inside of it is still the original g of x, still the original inside. And what ends up happening is the derivative of this e raised to the x squared plus 4x plus 6, the derivative of that is the same thing it was to start with. And well, that's how we typically think of e working, right? The derivative of e is itself. So it's itself, and we even copy this part as well. Okay, but then we're going to multiply off to the side, and we'll put some parentheses here. Now here's where we take the derivative of our polynomial, and the derivative of that is 2x plus 4. So we've got the constant multiple, then we've got the derivative of the outside times the derivative of the inside. And if this was a quiz or a test, and all it was asking you for is the derivative, you could stop right there. The simplified version, not a whole lot to do. You could distribute the 2 inside of this and maybe put that in the front. I guess you could say that's simplified, right? Okay. We've got some more examples coming up. We're going to take this a little bit deeper. See you there.